Okay, so talking about the mouse and communicating with the corresponding node, we will have the issue of who's supposed to manage and which element actually should manage this. Now, even if we were to actually pass a friend or we're going somewhere else, sometimes you just let your roommate know and say that, okay, I'm going to go here. If somebody comes looking for me, let's say Mr. X comes looking for me, could you please tell him to wait for a while and I'm going to go out and come back later. So now if you don't inform your roommate and they just went out thinking that you'll make it back in time, when Mr. X comes to your room, that's going to be a big problem. Now it becomes a big issue whether you want to write a note and leave it on the door, or you want to pin it on your sideboard, or you want to inform your friend, or you want to text the person a message. It all depends on actually how you will optimize this entire situation. Now, similar in that line of view, coming back to the IoT, as we discussed just now, the integration of IP into wireless sensor network is the actually realization of IoT itself. Now, when you look at this, without mobility, now the idea of actually having IP on the move is fundamentally one of the crust of the issues that I am going to share with you today about mobility management. So what happens when you move is among the things that actually deal with the mobility management per se. Now if you look at an element which moves, you will find that several things will happen. Number one, when they move they have a velocity, which makes it hard because it's so much easier working with things which are static because they don't move, and you don't have much issues because they don't consume a lot of energy. Now, apart from that, what are the issues that we actually have? About two issues when they move from one point to another point is they will have two issues. One is about the ID, and the other issue is actually about location per se. Now, so when you look at mobility management issues, enabling mobile devices to move from one point to another point means that we want the connectivity to be seamless. Now, what will happen with the connectivity is, because when we start from point A, we have an IP address, let's say A. And when we move to point B, we have IP address B. Now the assignment of these IP addresses given to per node are based on the IP allocation method or strategy which is being deployed. So when we look at these issues, now what happens is, now when you move and your IP addresses move, now remember, going back to what I told you initially, is that IP addresses, basically how many of us in this lecture hall actually have a unique IP address. Now the idea is, because when you have a unique IP address, that means it'll be nice that when we are born, apart from the birth certificate we are given an IP address. So if anybody wanted to communicate with us through data communication, they'll just have to contact us through, just like our identification number, through an IP address. Now, as we all know that that's feasibly not possible, because the allocation of IP addresses are given based on strategies, and many factors actually govern that, based on authorization, security issues, demographics, geographical boundaries, and so on. So when a node moves, let's say for example, call this node A. Now when node A moves from point A to point B, what happens with node A is, node A's IP changes. Okay, it's just like making a phone call. Now if I had a handphone, okay, and I moved from Malaysia to India, and as I told you, this would be considered to be a roaming, but people would still be able to call me on this number. Now this makes it easy because just as you know, when you call someone who's traveling abroad, the ringtone is different. Okay, now why? That is to tell you that that person has migrated, gone off somewhere else overseas, and your charges are going to be different when the person answers the call. Now it's interesting to know that when you were to call someone, based on somebody were to call me in India, I'd pay the bill. That means I'd pay maybe 2 ringgit 50 cents per minute, as opposed to 13 cents per minute if I were to make the call. Now the person calling me from Malaysia is also using a Malaysian number, but why is that I'm paying for the cost of this communication for that person to communicate with me and for me to receive that call is because I know where I am located. Now the person calling me doesn't know, therefore I have the right of refusal to actually refuse the call or not to answer it because I know the implications of the call. But somebody calling me and not knowing me where I am because the identification is the same, it's unfair to the caller. So in the similar philosophy, you will have actually two main things. One is the identifier and one more for the location. Now the location is actually fundamental in actually making the communication happen because we need the IP address. Therefore we need the exact IP address, and that IP address is actually based on the actual location where the node is at that point. So the idea of mobility management within the IoT becomes very interesting because the idea is for us to actually manage two main things. One is we want to maintain a similar ID because we don't want people or corresponding nodes with us having the difficulty to always trace where we are. Okay, number one. Number two, how are we going to manage a unique identification while our IP is moving? So the issue is we got to come up with an intelligent strategy where IP will actually be representing an identifier as well as a location. Or that's the issue if you look at it. So in resolving this issue, we will have many solutions that we already have many solutions that have been proposed, and we'll go through some of them. Now, so basically the issue of when a node moves, the mobile IP, the IP changes, and in another fundamental philosophy, it's called a mobile IP. That means an IP that is associated to a moving node. So the issue now is how do we manage the change of IP, but at the same time we want a unique identifier. Therefore this seems to be the forefront, the identifier, and I keep communicating with the identifier as opposed to communicating against an IP address purely. Now if you look at this, there are many solutions to this, and we will go through some of the solutions today. So basically mobile IP was proposed by IETF as a solution to sorting out these issues. Okay, so if I were to give you a 10 minutes time now, which I won't because I'm still on video conferencing, but if you were to be given just a couple of minutes for you to ponder how can you achieve a unique identifier associated to a node for a period of time, and behind the unique identifier you have a constantly changing IP as you move. Now you can imagine if I were sitting in a car and I were driving, alright, and the car was moving at 130 kilometers an hour. Now you would be able, actually you shouldn't, between 80 to 110 kilometers an hour, but you could imagine if the distance from Trichy to Coimbatore is, let's say, 300 over kilometers, and I were to be traveling around, let's say, 80 kilometers an hour, it would approximately take me 4 hours to move, okay, to travel from Trichy to Coimbatore. Now, as I move this 4 hours, I'm going to transcend 300 kilometers, and you can imagine the number of IPs that are going to be changing because I'm going to be connected to them. Now, that's number one. Number two, the speed of movement. At 80 kilometers an hour, there are many issues that you will have because the process of handing off from one base station to another base station, process of handing off and getting your IP addresses involve a lot of issues. So basically the first solution to these issues, you can see started with mobile IPv4, and then we moved to IPv6, and we have the mobile IP extensions, FIMRP and hierarchical mobile IP. Then we moved to the concept of proxy mobile IP, and then we have other solutions that are along the way, which is constantly growing. Now there are many issues in proposing solutions that we have. There are many issues that you have in terms of solution. And the idea of these solutions is in order for us to maximize the energy we have, we optimize the energy consumptions, and we also want to reduce signaling cost. And the issue is now two things. One is device or the node itself. Okay, that's it. That's one issue. Then you have also the network. So the issue is now managing this mobile or mobile IP becomes an issue of which entity is actually going to manage it. Is it going to be the device? Is it going to be the network? Now when you look at certain characteristics, okay, this is like assigning a task to a particular staff. Now when you want to give a certain kind of task, okay, some people are, or some staff are oriented around multitasking. So you can give them a project about research, you can give them a project about publication, and you give them a research about administrative work all at one go. Okay, and the person will still be able to run it. Now there are also staff that can execute pure efficiency, but based on sequential job processes. So what you do, you assign them a task, you wait for them to finish it. After they finish it, you give it back to them. So basically, when as a manager of an organization, my allocation of tasks in order to get the task completion done in the best manner will actually be based on the issue of us deciding which task is associated to which type of employee. So if employee A can do multitasking, I give the employee that task, and that employee will be able to do it in its best manner. If a task is, if an employee can only do sequential tasks, then in order to get the best out of the employee, I would give this. Now, the similar case happens when you look at the device and the network. Now, when you talk about devices in IoT, they are devices which are sensory devices. There's a wide spectrum of devices. Now, if you look at each end, one is high powered and one more is, you know, the definition of wireless sensor network is actually nodes which are small. They have constraints. I wouldn't say a lot of course, limitations and constraints in terms of battery, energy, in terms of computation power, in terms of memory, and so on and so forth. So deciding which entity should do this job, or should it be cohesively done together with this, is among the type of solutions that we'll actually have for us to deal with mobility. So that's the interesting about. So before IoT actually came into the scenario, the issue of mobile IP is actually already present because of the movement of the nodes. Now, if you look at this, mobile IP has fundamental thing of two beautiful new entities. Okay. Now, in order to solve these issues, what issues? That means when a node moves, how is the corresponding node going to communicate with them? You will have several entities now which are important. Number one, we have the mobile node, which is the node that's going to move. Number two is the corresponding node, which is also a host trying to communicate with this mobile node. Number three and number four. So in order to solve this, what happens is we actually come up with additional solutions, meaning that if you look at additional solution means additional components. So for example, if we wanted, we didn't have a security guard in PSG, for example. Now the last time I came to PSG last month, it was nice because the minute I entered, the guard told me, hold on ma'am, may I please know where or who do you want to see? So I said, I'd like to see, I'm here for the IoT conference and I'd like to go to the hall. So what he did was, after he authenticated me, then he let me go in and he showed me the way and I met the person responsible. Now if we did not have that guard there, now what would happen is, once I enter the PhD, I would actually have to probably ask all the students around, do you know where's the conference? 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 And that would actually be very overloading or overwhelming for me. So having a guard present makes it very easy because the guard can stop bad people from coming in, stop people who have no idea for people to who are coming in, and we can also have guards who are trying to authenticate, give us direction, and so on and so forth. So the presence of a guard facilitates our work. So while the guard is doing his job, we are still able to facilitate. I'm still able to communicate with the lecturers and to talk to them, to meet them. But that lecturer doesn't have to be at a point. I don't have to keep calling lecturer and say, I'm coming in 10 minutes, can you please wait in the front, can you please wait in this building, and so on and so forth. So the presence of the guard facilitates this holistically. Okay, so now what did mobile IP, what was present in mobile IP is two new elements were introduced, which is the home agent and the foreign agent. So these two new elements have to be included into the solution in order to facilitate the movement of this entire task. Okay, so when you look at that, you have a home address and you have a care of address. So the idea is that if you had a corresponding node communicating with you through the network, and you had a mobile router and you had the mobile node. So now let's call this mobile node A, and this is corresponding node. And this is, let's say, router A, and we have another router B here. Okay. So if you were to have a quick scenario of this, now what is the issue when the corresponding node is communicating with router? We will actually have a communication this way. So now corresponding node knows that mobile node A is registered to router A. So if I had an IP address A.B.C.D, right, that's my IP address. So this is happening at T1, time 1 second. Now at T2, mobile node A moves to a new location. So this is mobile node A at T equals to, let's say, 5 seconds. So what will happen is, when the corresponding node comes here to communicate, this is no longer present here. Now what will happen is, the issue now is, after mobile node A registers itself to router B, you will get a new address E.F.G.H. So our corresponding node, because at time T use A.B.C.D, now at T 6 seconds also uses A.B.C.D, goes back to this location, and this doesn't exist anymore. Now, because it doesn't exist anymore, what will happen is, you will have a breakage in the communication. And now comes to the part that I would like you to just spend about 2 seconds to just think now. Okay, once this node, mobile node A moves, who's going to be responsible to tell the corresponding node that it has moved and this is its new address? That's one. Number two, I'd like you to think also the speed of movement. Okay, so if I'm traveling at, let's say, 10 meters every second, or compared to 110 kilometers, or let's say I'm traveling 1 meter, okay, every hour. That's really slow. Okay, that will be kind of easy to manage, because by the time I decide to move, okay, or 1 kilometer an hour, by the time I move, I have enough time to inform and move, because I am moving actually in a very slow manner. Now, if I were to increase that velocity and move to 110 kilometers an hour, now what would happen actually in this entire scenario